So in this fourth lecture of data visualization, I am going to show you how to resize the canvas, how to resize the figure, and how to save the figure in the JPEG format in your local drive, and the clarity of how to save that. So welcome to Learn with Python channel, and let us waste no time and get into the class. So let us open the Spider. This is our earlier program which we have created a canvas with two graphs, one as axis 0 and one in axis y. Now I wanted to save this graph. In order to save this graph, I need to change the size of this canvas, size of the complete canvas. So to change the size of the canvas, what I am going to do is, in this subplots function, I am going to add one more variable called size is equal to 8,4. We are going to see what this 8,4 is in a second. See, look at this. The size of the canvas has been changed. I did not change it manually, but it got changed automatically with the help of 8,4. It takes 8 parts in row wise and 4 parts in column wise. So if you want to play around, you can play around with the different numbers. 10,4. It's going to give you a different graph size. Okay. So let us save this file with the help of fig.save. You can rename it as sample1.jpg. Okay. Now if you see the working directory, my working directory is having only these 3 files which we have created in the past lectures, and there is no image file. I am gonna run this file now. Right. So this image has been created with this graph. Let us close this and go to our working directory again. Refresh, and here you go. This is the sample one. Let us open it and view. So whatever the graph we have seen when we have created, when we have run the program, so the same graph we are viewing it in a image JPEG format. So if I try to zoom in, so it's losing its clarity. It's not the same as what we see when it is zoomed out. So how to increase the dots per inch, DPI. So for that also there is a function which we have. Here in this subplots, we have to add one more argument. DPI is equal to 500. The more count you give for the inch, the more number of dots you give in the inch, the much more clarity it's gonna give, and the image size also will get increased. Now currently the size of the image is 37. Let us try run this program and see how it is gonna change. So look at this. Here the graph size is increased, and let us see here. Look at this. From 37 KB, the size was increased to 350 KB. Let us open this. So this is how it is looking. Even if we zoom in also, you clarity is going to stay as it is. Okay, you can go ahead and play with different numbers, and the more DPI you give, the more clarity you get. And the next one is you must be adding legend in the sense, once if you run this comment it out, okay, when you run this graph, you're going to see what this line represents. That is called a legend. And let us add legend to the graph. So in order to add a legend, first you have to create label to that axis. So to create a label, you have to use the keyword label, and you have to enter the text, which is x comma y. In this axis, the label is y comma x. So you have created a label for this axis. Now you just have to add legend. So in order to add the legend, just like earlier how you have added the title, just axis 0 dot legend. So as of now, you don't give anything. In the legend function, don't pass any parameters. Save, run. So now you can see for axis 0, x comma y, that's how we have taken, and for axis 1, y comma x, that's how we have taken it. Now, so this is the position we have in this. The system has divided and placed it here. Now if you want to change the position or location, you have to give some arguments in the legend. Let's try doing that. Now let us see. Log and loc is equal to 1. Let us see how it is shown. We will not add that the location 1 in first axis. We will compare how it looks. Location 1 and location without any location. See here. This location 1 is placing the legend at this corner. Without any location preference, the system is placing the legend in this corner. If we change to location 2, what is this? So it's going to, it gave us here only. So next, if we give location 3, what does this figure 3 shows? Yeah, see here. So this is location 1, this is location 2, this is location 3, and obviously this must be location 4. Let us try and see it. Yeah, this is location 4. So with all these 4 figures, first figure is just location 1, second figure will be location 2, third one location 3, fourth one location 4. So by default the system took this location based on the parameters. If you want to change, you can change the position of the legend also. Yeah, and one more thing I just wanted to add here is, if you wanted to add one more line in the same axis, all you're gonna do is copy in the same axis of 0, you're going to add x. You can assign it to a variable and you can add a variable here, or you can directly give the equations, or no problem. So the label will change to x raised to the power of 3. So let us see how this is going to work. Let us change. Okay. See, now here it is showing two lines. One is x comma y, which is x and x raised to the power of 2, and the second line, which is in orange color, which we haven't given anything. The system has decided automatically. Even if you want to change it to red or blue or green or anything, you can use it with the help of this inverted commas with RGB colors. Okay, next, so this is how x and x raised to the power of 3 graph looks. Even if you see the legend, the x-axis and y-axis values also has been changed. So this is how we can add two lines to a single plot. Two lines to a single plot. See, for 0 axis 0 is only a single plot, but we have added two lines. One is x comma y and the other one is x and x raised to the power of 3. So multiple lines. So thanks for watching this video. In the next video, I am going to show you how to have more options in editing the line of the graph. Okay, thank you for watching.